Bismillahirrahmanirrahim. In this session, we will discuss section 1.7 energy, power, work and power from O level and IGCSE physics. And in this session, we will discuss some practice problems and from Hodder's book, page 63. The first question, we have to calculate the kinetic energy of a ball of mass 0.4 kg moving with a speed of 80 meters per second. So we have a given mass 0.4 kg and it is moving with a speed of 80 meters per second. So this is 0.4 kg and it is moving with a speed of 80 meters per second. So the formula of kinetic energy is half mv square. Here we have half and m is 0.4 kg and the velocity is 80 meters per second square. And here on solving we have obtained this 1280 joules. So this is part 1, question number 1. And question number 2, we have to calculate the kinetic energy of a ball of mass 50 grams. The ball mass is very small, grams, and moving with a speed of 40 meters per second. So the mass is given as 50 grams. So this we will divide this by thousands to convert it into a kilogram. So from kilogram, this is equivalent to 0.05 kilogram because we have divided this 50 grams with 1,000, so it becomes kg. So this velocity is 40 meters per second. So we will multiply this half with this formula. Ek is equal to half mv square. This mass is 0.05 kg, while the velocity is 40 meters per second square. So this is equivalent to 40 joules. So calculate the gravitational potential energy gained by by 0.2 kilogram mass raised vertically by 2 meters. So the gravitational potential energy gained by 0.2 kilogram mass raised vertically by 2 meters. So the mass is 0.2 kg and it is vertically lifted upward 2 meters. So the gain in gravitational potential energy is defined as mgh, where the mass is 0.2 kg and g is 9.8 newtons per kilogram and the height is 2 meters. So on multiplication, this divide by this. So this is newtons meters, which is equivalent to joules, and on multiplication we have obtained this 3.92 joules. So the gravitational potential energy obtained by the mass is 3.92 joules. Calculate the gravitational potential energy lost by a 0.4 kilogram mass which falls vertically by 3 meters. So this 0.4 kg mass is falling vertically from a height of 3 meters. So the mass is 0.4 kilogram and the height from where the object is falling is 3 meters. So the gain in gravitational potential energy is the potential energy lost. So this is lost. This is not the gain, but the loss of the gravitational potential energy is mgh 0.4 kg 9.8 newtons per kilogram and this height is 3 meters. So this is on multiplication we have obtained this 11.76. So this is the loss in gravitational potential energy because the object is falling, so the energy lost. So this is lost in gravitational potential energy is this. So we have to make this correction here. Now put this into practice. Page 64. A stone of mass 2 kilogram rolls off the flat roof of a building and reaches the ground with a speed of 10 meters per second. So this 2 kilograms roll off the building with a speed of 10 meters per second. So this mass is 2 kilogram, and this velocity is 10 meters per second, and this kinetic energy formula, and from this on solving we have obtained this 100 joules. B part, the gravitational potential energy of a stone when it was on the roof. The gain in gravitational potential energy is 100 joules. So it was 100 joules, that's why it converted into a kinetic energy when it's fall down to the ground. Neglect the height of the roof, neglect air resistance. So we have to find the height of the roof. So this energy is equal to mgh. So initially the energy in the object stone was this 100 joules. So this is 100 joules. So this mass is 2 kilogram, and g is 9.8 newtons per second, and then we have to find this height is equal to this 100 joules divided by these two numbers. So this 2 kilograms and this 9.8 kg. So this kg with kg cancels, and this joules divided by this newton is obtained as 5.1 meters. So on solution, on solving, on divisions, so this is obtained as 5.1 meters. So the height of the roof is 5.1 meters. A football mass of 0.4 kg rose off a 30 meters high cliff. Mass of the football is 0.4 kg and it rose off a 30 meters high cliff. Calculate the speed of the football when it lands on the beach, neglecting air resistance. So mass is 0.4 kg, height is 30 meters, and speed of the football is have to obtain. So this energy converts into a kinetic energy. This potential energy at the height is converted into this. So this 30 grams. So we have this half mv square is equal to mgh. So on solution, this mass this cancels out, and this 2 is here. V square is equal to 2gh, and taking square root, and then v is equal to 2, and this g is basically 9.8 meters per second square, and height is 30 meters. So on solutions we have obtained this 24.25 meters per second. Test yourself. Identify the way by which energy is transferred to in the following process. A battery is used to light a lamp. The batteries are compact source of chemical energy which can be transferred by an electric current to devices like lamps, heaters, or motors. So batteries are a compact source of chemical energy. It contains chemical energy which converts into electrical energy and transfers electric current to devices like lamps, heaters, motors, or any other electrical devices. A ball is thrown upward. Whenever a ball is thrown upward, gravitational potential energy in the form of energy an object possesses by virtue of its position. So as long as it reaches the height, the potential energy gained by that object or a ball. Water is heated in a boiler. So this is internal energy. Heating water in a boiler transfers chemical energy stored in the fuel to the internal energy stored in the water. This fuel energy in the fuel, chemical energy which is stored in the fuel, will be utilized to increase the internal energy of the water. So it will be stored in form of internal energy in the water within a boiler. This phenomenon occurs. State 2 energy is stored in the following: fossil fuel, food and fuel like oil, gas, coal and woods are concentrated source of chemical energy. Food and fuels also contains energy like oil, gas, and coal and woods, and are a concentrated store of chemical energy. Hot water thermal energy is transferred by conduction, convection, and radiation. In hot water, the thermal energy is transferred in the form of conduction, convection, and radiation. A rotating turbine is a mechanical energy. In a rotating turbine, energy is a mechanical energy. A stretched spring is an elastic strain energy. In a stretched spring, energy is stored in the form of elastic strain energy. Calculate the kinetic energy of a 1 kilogram trolley traveling at 2 meters per second. So mass is 1 kg and it is moving with a speed of 2 meters per second. So the kinetic energy is given as half mv square, which is half 1 kilogram 2 meters per second square is equal to 2 joules. This 2 grams, which is equivalent to 0.02 kg bullet traveling at a 400 meters per second. The mass of the bullet is 2 kilogram, which is 0.002 kilogram, and the velocity of the bullet is 400 meters per second. So the kinetic energy is half mv square. So this is obtained as 160 joules. The energy in the bullet is 160 joules. A car 500 kg car traveling at this 72 kilometers per hour. The mass of the car is 500 kilograms and the velocity of the car is 72 kilometers per hour. 72 kilometers per hour, and we have to convert it into, so we have this 1000 meters, 1 kilometers. So this is a unity term. Similarly, 1 hour is equivalent to 3600 seconds. So in this way, this kilometer will cancel with this kilometer and this hour will cancel with this hour, and we have left with this meters per second, and we have to 72,000 divided by this 3600, and as a result we will obtain this 20 meters per second. So this 72 kilometer per hour will be obtained as 20 meters per second, and we will place this 20 meters per second here and in the kinetic energy. So we will obtain this in the form of this. So we can see that if the mass is very high, the kinetic energy will be high, and the velocity is also very high. Although the velocity is 20 meters per second as compared to this, but the mass is very high. So that's why the kinetic energy by this car is 1000 joules or 100,000 joules. What is the velocity of an object of mass 1 kilogram which has 200 joules of kinetic energy? So V is, we have to obtain the velocity. Mass is given as 1 kilogram and the kinetic energy is 200 joules. So kinetic energy is half mv square. So this V square is equal to 2 times Ek divided by m. This is 2 and this kinetic energy is 200 joules and divided by this 1 kilogram, and we will obtain this 20 meters per second. Calculate the gravitational potential energy of 5 kilogram mass when it is 3 meters and 6 meters above the ground. So for 3 meters, this is mgh, 5 kg, this 9.8 and this 3. So this is 147. So in the second problem, the height is 6 kg by rest assuming the same 5 kg and 9.8. So this value is double because this is 3 meters and this is 6 meters. The height is double, so the kinetic energy is doubled. It is estimated that 7 into 10 to the power 6 kilogram of water pours over the Niagara Falls every second. This much mass of water enters into the Niagara Falls every second if the pours over, and if the falls are 50 meters high, and if the energy of the falling water could be harnessed. So this energy could be, if it can be contained, what power will be available? So mass of the water pours over the Niagara Falls every second is this. So every second per second. So this is per second, the rate of mass flow. So we have to write this per second here. So height is 50 meters, and we have to obtain the power. Power is equal to this. So this is kilograms per second. So this is kilograms per second because rate of mass of flow, and this is G is 9.8 newtons per kilogram, and this height is 50 meters. So we have to write this second per second here, and m here we have this dot m dot. So on the multiplications we have obtained this. So this 3430 megawatts, this much energy or power can be obtained with this. If all the energy can be harnessed, then we can obtain this much megawatt of energy. In the next section we will discuss this